Here we go. Here we go. You guys ready? All right. So let's see. Implicit differentiation. First, we define the difference between implicit and explicit. Explicit is a function that is described clearly. So when someone gives you explicit instructions, they're being just blunt. You're going to follow them verbatim. Does that make sense? Like y equals square root of x, an implicit equation in the form of y squared equals x. This and this are actually the same. You just this is explicitly where we just took the square root, just like you said, Houston. Not all implicit equations can be written explicit. Let's see if we can do example 1. All right, so this is what we call implicit, and we're gonna take the derivative. But look what I'm gonna slow down. And I don't know, was I screaming? Sorry if I was screaming. We're taking the derivative. What does this mean, dy dx? We're taking the derivative with respect to x, right? dy dx. So the first thing I asked, think of this like chain rule. So think of this like y close it squared like that. Think of it like that. And I think it becomes easier. So I'm taking the derivative of the left-hand side. So what is the derivative of this y squared? 2y. Bring the 2, leave the y alone, power 1. And then I'm taking the derivative of the inside. What's the derivative of y? 1. But am I taking it with respect to y or respect to x? So then I write dy dx because I took the derivative of y with respect to x. Dy dx is y prime. See, the derivative of the inside, y prime. Huh? Okay. Y equals, when I take the derivative of y, what do I say? Y prime. So I could have, I don't know, maybe you guys like this better. Y prime. I'm taking the derivative of the inside. Do you guys see that? Equals, what's the derivative of x with respect to x? 1. How do we feel? How do we feel right now? Okay, I'm going to rewrite it. Remember that y prime does in fact mean dy dx. So I'm going to write 2y dy dx equals 1. Have I confused anyone? Okay, I am solving for dy dx. Chop, why are you solving for dy dx? Because they told me find dy dx. And that's the second yawn. That's another demerit if you do it again. I'm going to divide by 2y. Whatever you do to the left, you do to the right. So dy dx equals 1 over 2y. There it is. I do not have to put it in terms of x because this is implicit. It can have x's and y's. How do we feel? Okay. Yeah, don't worry. We're gonna do a whole bunch. We're gonna do a whole bunch. I just divided by 2y. This is all a product. 2 times y times dy dx. Okay. Here we go. Now it says, maybe I should have done this. You know what? Let me change my notes for next year. Do this first.
Oh, so you're getting things.
No. These are just fresh notes. All right, now let's solve explicitly. So that means I have this y squared equals x, and I want to do it in terms of, I want to get y by itself. So what do I got to do? Take a what? So y equals square root of x, and now I'm going to take a derivative, and technically I should be getting the same thing, right? So let's see if that is. Remember that the square root of x means x to the 1/2. So I'm going to write y prime or dy dx. Let me put dy dx. dy dx equals 1/2 parenthesis, leave the inside alone, x to the negative 1/2 times 1 times the derivative of x with respect to x. So there it is. Let's write it 1 over 2 square root of x. Don't worry, I'll wait for you guys to catch up. Chop, this is not the same as this. Yes, it is. The only difference is that this one has a y, but notice what was y. So 1 over 2y. It's the same. Do you guys see that? It's the same. It's just written differently. That's all.
So it's kind of like the one that we did for U of H. That one problem where you were plugging in y. Does that make sense?
I don't remember.
Okay, I'll show you.
Okay.
So before we solve, do we want? Never mind.
Yeah, don't worry. We're going to do a whole bunch. Go to the next question. Finding the slope on a circle. We're going to go slow. From your pre-cal days, do we know that this expression right here is a circle? It's a circle centered at the origin with a radius of 5. Good job. It's a circle centered at the origin with a radius of 5. So here's how it looks more or less. Here's my axis. I'm going to say here's 5. This one's -5, -5, 5. And I'm going to try. I'm not the perfect. I know with technology I can just put two shapes and insert a circle, but there it is. There's my circle. Okay. If this were to ever be a multiple choice, there should be answers that you should delete. Think about it, guys. If you're at the point 3, -4, that means you are on quadrant 4. And in quadrant 4, all my tangent lines have slopes that are positive. Yeah. See, do you guys see all these tangent lines? They all have positive slopes. Do you guys see that? So when I take the derivative of this, I better get a positive slope. Yes. You see, if I have a point right here and I call that 3, -4, I want you to see the tangent line. Look how that tangent line looks. And that tangent line is increasing left to right, so it needs to be positive. All right, so here's the mistake that you guys make the most. Maybe I shouldn't even mention that. I don't know. You guys like to call, like I told you guys to take the derivative, but we're taking the derivative implicitly. So you guys like to go y prime equals. Like there is, guys, it doesn't say y equals, so you don't start like that. So how do we start? Chop, how do we start then? Well, I'm finding dy dx. So that means I'm taking the derivative with respect to what letter? X. So here's what you say. What is the derivative of x squared with respect to x? 2x. And if you want to, you can also do 2x dx dx. That was an x with respect to x. Do I confuse you guys when I say that? Yes. All right. Well, here, hold on real quick. So let's do a side note real quick. X squared here like that. And I'm going to put parentheses. If I told you to take the derivative with respect to x, so I'm going to write d dx, giant parentheses. So that means this. 2, leave the inside alone, x, close. And a long time ago, I told you, I'm taking the derivative of this. This is an x, dx with respect to x. See, dx is over 1, is just 1, so that's why we don't write it.
I think you only confuse us whenever it's like x squared. Does that make sense? Like we understand it whenever there's like another value within it. But I think since
I guess we can say
yeah.
X prime.
So is the derivative of x not working?
It is. I was trying to, okay, maybe I should just say, is it an x? Okay, let's start again.
Whenever
Yeah.
it's 1, we understand it. Whenever it's
Yeah.
every other value, we
Yeah.
understand it.
Yeah, don't worry. Look, we'll fix it right here. Real quick. I already know how. I'm taking the derivative of x squared. Is that an x? So it's going to be normal. What's the derivative of x squared? 2x. Now, this right here, it's like doing this. What's the derivative of y squared? 2y. Is y an x? So you got to put on the side dy dx. If it's not an x, you put if it's a y, what if it would have been a z? dz dx. What if it would have been a w? Because I'm taking the derivative with respect to x. Now, okay, side note, if I took the derivative with respect to w and I have w squared, then that would just be 2w because I'm taking the derivative with respect to w. So you don't have to, I guess you could write dw dw, but that's just 1. Do you guys see what I'm talking about? Okay. Equals, what's the derivative of 25 with respect to x? 0. You are done with calculus. That's it for calculus, guys. The rest turns into what? Algebra. Here we go. Look, we're going to get better. We're getting better at algebra every time. Move the 2x to the right. Chop, what are you doing? I'm just trying to isolate dy dx. 2y dy dx equals -2x. Are we still okay? Yes.
Why do we take the derivative to respect of x and not y?
Because I want to find the slope, and the slope is dy dx, the instantaneous rate of change. Are we still okay? Okay. How do I get dy dx by itself? Divide by 2y. dy dx equals -2x. Yeah. It reduces to... Chav, I thought you said it's always going to be a positive slope. Relax. What values do I got to insert? And notice that one of the values is already negative, and negative divided by negative is a positive. So I'm going to write dy dx, and I'm going to put Here's how you say evaluate with a line like that. 3 comma negative 4 close equals, and I'm just going to plug in so negative 3 over negative 4, which just equals 3 over 4. And that's a slope. Did they just ask for the slope? Of the tangent line at 3, negative 4. Are we okay, guys? Okay. What's up? How do we feel? You feel okay? We should have what? Here we go. I still didn't hear, but oh, nap time? No. All right. Here we go. You guys ready? We're gonna go slow. Show the slope dy dx is defined at every point on the graph 2y equals x squared plus sine y. So it means defined. So that means as long as I don't have, you're probably gonna have a fraction. As long as you don't have a 0 in the denominator. Cool or not cool? All right. So we got to take a derivative. Here we go. I'm taking derivative with respect to what letter? X. So what's the derivative of 2y? 2
I'm so sorry.
is y and x. So what do I put right next to it? There it is. That's the left-hand side. Equals, what's the derivative of x squared with respect to x? 2x. There it is. Nothing crazy. Are we still okay? What's the derivative of sine y? Cosine. You got to keep the argument. Is that an x? dy dx right next to it. Kind of like chain rule. The derivative of the y with respect to x. Are we cool? We are done with calculus. Now it's just what? Algebra. So, well, that's why we're doing it right now. Look, we're getting better at algebra. What are we trying to get? dy dx. So get the dy dx's all together. I'm going to move this guy, that's my product, to the left. So here we go. 2 dy dx minus cosine y dy dx equals 2x. So catch up to here.
I like that you have the window open, Joe.
Oh, thank you, miss.
Can we turn off the lights?
No, not right now. All right, next. I'm trying to isolate, what am I trying to solve for? So I'm going to factor out dy dx. So factor it out. dy dx, parenthesis, 2 minus cosine y, close it, equals 2x. So catch up to here. Yes. We're trying to get dy dx by itself. So just divide. Yeah, divide. dy dx equals 2x in the numerator, 2 minus cosine y in the denominator. No, the 2's can't cancel out because of the minus. Algebra, miss. Okay, are we still okay? All right, we haven't answered the question. It says, show that the slope dy dx is defined at every point on the graph. Okay, so it's defined. Why? Because will I ever get a 0 in the denominator? So I'm going to write, since 2 minus cosine y will never equal 0. And then if you were to put a side note, so what's my side note? Side note, cosine y is between -1 and 1. I know that for a fact because we all took pre-cal. The amplitude is 1 in the front, so it's always going to be either between 1 and -1. Since 2 minus cosine y will never equal 0, comma, dy dx is defined, I'm just copying now the sentence stem here, is defined at every point on the graph. What graph? On this graph. On the graph 2y equals x squared plus sine y. However that looks. How does it look? Type it on Desmos. See how it looks. I don't know how it looks. Cool or not cool? How are we feeling? Okay. In a little bit, when you practice delta, we're not insulting your intelligence. They're going to start with baby steps. They're going to take derivatives with different letters. Chop, what are you talking about? Okay, put a line. Let's go ahead and show you what I mean. Relax, relax. D dx of 5x squared. What's that? 10x. Yeah, nothing crazy, right? All right. What if I do d dw of 5x squared? 10x is it, but is it a w? So then I write dx dw. All right, let's do another one. D dw of 5w squared. 10w. That's it. Because it's with respect to w. Ask. Ask to the third power. Ask to the fourth power.
That was aggressive.
Oh.
Ask.
Miss, I did not say it like that. I have it on recording. Yeah, I'll play the recording. I mean, this is not a court, but we'll. Okay. Ask.
W of 5x.
Oh, that's what we did. dw of 5x squared. 10x with no, that's not a thing. Yeah, it's d over. Yeah, it has to be with respect to the letter.
What if it's dx of
D dx 5w squared. That's the same logic. So 10w, but is that an x? dw dx. Think of it kind of like chain rule. See, like that. See what I mean? Okay. Are we still okay, guys? All right, here we go. Let's go to the next one. I actually want to see this image in a little bit. We'll go to Desmos in a little bit. Find the tangent and normal to the ellipse, x squared minus xy plus y squared equals 7. All right, the number one mistake that we make is we forget to distribute. So put a parenthesis on the xy. I'm taking the derivative. What do I need to find a tangent line? Point of slope. dy dx always means slope. Always. It always is change in y over change in x. Instantaneous rate of change. It means instantaneous slope, but for all intents and purposes, we'll just call it slope. Cool or not cool? All right. Here we go. You guys ready? I'm taking the derivative with respect to what variable? X. So we're going to take the derivative right off the bat. What is the derivative of x squared? 2x. All right, 2x. Minus, that minus is this minus. Parenthesis. What rule do I got to use for the xy? Product. First, x times derivative of the second. What's the derivative of y? dy dx. Or I guess you could say y prime if you want. dy dx plus second y times derivative of the first. What's the derivative of x? 1. So I'm not going to show it. I'm going to close my parentheses. Equals. Oh yeah, I still haven't finished. Good job. I was testing you guys. Yeah, that was it. Plus, what's the derivative of y squared? 2y dy dx equals 0. You are done with calculus. Now what are you going to do? Just algebra. Yes. That's the derivative of 7 is 0. So all we're doing, guys, is getting the dy dx by itself. So what am I going to do? Well, first I got to distribute here. So let's distribute. So here we go. 2x minus x dy dx minus y plus 2y dy dx equals 0. Yes, but there's nothing to combine. Are we still okay? Okay, anything that does not have a dy dx, I'm moving it to the right of the equal sign. So it's going to change signs. I like to have positives in the front, guys, so I'm going to write the 2y dy dx first. 2y dy dx minus, x dy dx equals positive y, because I like to have positives in the front, minus 2x. Yeah, you can say negative 2x plus y. Okay, time out. Let me tell you why I prefer, this is what a common, okay, I'll just say it. Sometimes when you guys move stuff to the right, and let's say you write that negative first, especially if it's a fraction, that negative sometimes starts floating. and then eventually it looks like the whole expression is negative, and then the whole thing is wrong. I have seen it where the negative is so far off that the team says, nope, that's not the same expression that we have, and they counted it wrong. So for your sake, I would keep these habits where your expression starts with a positive. Do you guys know what I mean? That way you don't run into that issue where the negative just floats. Do you guys know what I'm trying to say? Okay. Yeah. All right, factor out dy dx. 2y minus x, close it, equals y minus 2x. And now what do I got to do? Yep. So dy dx, that's a d there, equals y minus 2x over 2y minus x. Nothing cancels. Don't cancel anything out. Yeah, it's not a product. So, all right, are we still okay? All right, I'm going to plug in what point? Negative 1, 2. So here you go. dy dx evaluated at negative 1, comma 2 equals, let's make sure, yeah, comma point. 2 minus 2 times negative 1. Yeah, we'll fix it right now. 2 times 2 minus a negative 1. So let's see what we got. 2 plus 2, 4. And then let's see, 4 plus 1, 5. So there's my slope. Here's my tangent. So I'm going to write the word tangent. I'm going to go y. You okay, miss? Y minus 2 equals 4/5 x plus 1. Do I have to do anything else? You can leave it like that. In a little bit, we'll figure it out. They also wanted the normal. Hey, relax. You don't have to. All you got to do is change the slope. The normal is perpendicular to the tangent. So all I got to do is, instead of 4/5, I'm going to call it what? Yeah, that's it. Y minus 2 equals negative 5/4. And this is why I like this so much. You don't have to change anything other than the slope. Let's see how this looks in a graph. Don't you guys want to see how this looks? All right, here we go. I'm going to take out Desmos. Can you guys give me the ellipse, the equation with the x squared plus equals 7. Yeah, that looks like, check out that ellipse there. That looks pretty cool. All right, let's do our tangent and let's do our normal. Don't worry, I see you, miss. Oh. All right, guys. No. To take a derivative, as long as we have a function or an equation. It can be. No, anything. All right, give me my tangent line, guys. All right, guys. Y minus 2 equals 4/5. Yeah, that looks like my tangent. Let me go ahead and put my point in there so I can see it. It was, what was my point? Negative 1, comma 2. Yep, there it is. Label. Yes. I'll call it A. All right, normal. Y minus 2 equals negative 5/4 x plus 1. Look at that. No, good job, you. Oh, but now you know. Cool or not cool? Okay, let's keep practicing. Let's go to the next one.
Is this one the derivative of the derivative?
What does that mean there? It means take the second derivative, yeah. You guys ready? All right, here we go. First, we got to take the first derivative when we're taking it to respect to what letter? Oh, yeah, sorry. Because they're doing this. Take the derivative of your derivative. So d, there's a d here, there's a d here, d squared y. And it really should be this. But it's understood in the math community that this means second derivative.
Write that down. Write that down.
So just make sure that you're aware of that. So when you pick up a textbook, it'll probably say this,
Oh, I'll never.
where that means nth derivative. Nth derivative. So if you see a 3 there, you see a 4, fourth derivative, 5, fifth derivative.
Negative numbers and like regular numbers, it's crazy.
Well, we're talking about positive. There is something called, you're not a graduate student, so we'll wait for there is something called there's like a half derivative and a 2, but yeah, I'm sure there's videos on YouTube. Go to YouTube. That's probably something that's way above. It's definitely above high school, and it's definitely above maybe even, math majors, the basic ones. Okay. All right. Yeah. All right. Here we go. You guys ready? Here we go. I'm taking the derivative with respect to what variable? X. What's the derivative of 2x cubed? 6x squared. No trouble there. And I'm going to take the derivative of 3y squared, but with respect to x, so what's that derivative?
Minus 6y dy dx.
Perfect, because it's not an x, it's a y. Equals, what's the derivative of 8? 0. So now we're going to get dy dx by itself. You're done with, we're not done completely because we have to find the second derivative. But we're going to have to isolate dy dx. So cool or not cool? Move the 6x squared to the right. Well, I already started. So negative 6y dy dx equals negative 6x squared. Are we still okay?
Why do we not take the second derivative right before we do that?
Oh, because we want to isolate dy dx before you can take a derivative. That way we can see what rule we're going to apply. You know what I mean? Yeah, because we want to get dy dx by itself first. All right. How do I get dy dx by itself? I got to do what?
Divide by 6y on both
Yeah.
sides.
So I'm going to have dy dx. Negative divided by negative is a?
Positive
So,
6x squared.
okay, 6x squared divided by 6y. So x squared over y. So that's my first derivative. So let me write it right here. dy dx equals x squared over y. So catch up, guys. Are we okay so far? All right, now I want to get the second derivative. So what rule do I got to use? Quotient. So here we go. I'm going to change colors so you can know that we're doing the second derivative. d2y over dx squared equals, that means second derivative. So I'm doing, what rule am I doing again? Quotient. Bottom. Oh, you guys tell me. What's the derivative of the top? Minus times derivative of the bottom, which is what?
Times y squared.
All over.
All over y squared.
Okay. We're almost there. Not yet.
Not combined, but
You see that, how it says dy dx there? dy dx is what? I'm going to insert that in there, guys. So here we go. I still have room here, so let me see if I can fit it in. So you can go ahead and multiply this. So I'm going to have 2xy minus, and then I'll go ahead and leave this like this, x squared times x squared over y, close, over y squared. Do you think you're going to see that answer like that? No. What do you think we're going to have to do? A whole bunch of what? Algebra. Relax. We're going to be fine. So here we go. When I multiply this one right here in black, what's x squared times x squared?
2x.
No, not 2x.
I mean,
Yeah, so here we go. D squared y over d. I guess you don't have to put this again. You can just write equals 2xy minus x to the fourth over y squared. Now, catch up to here. In order for you to subtract these terms, I need to have a common denominator in the numerator. Does that make sense? So I'm going to multiply this one on the left, in the upper left-hand corner, by y over y. So that turns to y squared over y. So I put in red what I'm doing that's different from the original. Are we still okay? All I did was I took this one right here and I multiplied by y over y. Because y over y is just 1. So it turns to y squared over y. We're still okay, guys? All right, here we go. Here's what I now have. 2xy squared minus x to the fourth over y, and all that is still over y squared. So catch up to here. That's a y, not a 4. It just looks like a same denominator. I thought I said denominator. Yeah, same denominator in the numerator. In the new, because I have a fraction within a fraction. So, okay. Are we still okay? Okay, keep, change, flip, or you can just move that y squared up, however you see it. So I have 2x y squared minus x to the 4th all over. What's y squared times y? That's probably the answer you were going to see. There it is, simplified. How are we feeling, guys? Okay, are we getting better? Yeah, go ahead. Yeah, give it a shot. See what you guys get. Take a 2-minute head start. That would have been a good one to put a poll, but next time. They're already telling you what the first derivative is, guys, so you just got to do it once. This is already the first derivative because they tell you. See, it says if the first derivative is 1 plus sine y. So what does this mean again? Second derivative. So here it is, second derivative. I'm just going to go ahead and just go bluntly into it. What's the derivative of sine? Cosine. You got to keep no, it's not negative, just cosine. And now I got to take is that an x?
No.
Okay, you're not done yet. You gotta insert that 1 plus sine y into that. So here it is, right? Cosine y, giant parenthesis, 1 plus sine y, close. I'm going to look for that first. I don't see it in there. Well, I do, but not like that. I got to do what? Distribute. And now you have cosine y plus cosine y sine y. Are we okay? All right. Oh, that's it. Practice. All right, guys, log into Delta and just practice.